Hello everybody, welcome to Bluemarblescience. Pseudoscience, anyone? How about part 2? Anthony Riley is upset with me because I didn't include part of his video. And I dropped some parts of it out just simply because I didn't think they added anything to his argument and would just require more clarification. But since Anthony feels he got mistreated, here's everything that I omitted along with a few observations of my own. You know, apparently one ass whipping is just not good enough. So, Gladys, that dumpster's still burning. Just throw a couple of logs on it. Here we go again.
FE is getting the message. The independent variable must be manipulated. It is the presumed cause. There can only be one independent variable. This is science. It's really worth being aware of what it doesn't say is science. It does not say that you can infer additional causes. You cannot substitute in or introduce or suggest alternative causes. That would fall outside scientific method because there's no citations that allow you to do it. We need a quick position with regards to what is inferred cause. From the University of British Columbia, Richard Johns writes, "Before we can discuss inference to the best explanation, we must be clear on what an explanation is. That involves the notion of causation and also of inference. There is an important difference between physical causation and rational inference." Tim Osman calls this logic and reason. Causation is a physical process that happens in the real world, whereas inference is a mental process that occurs in the mind of a rumpus or a geostrieber. There is a big difference between saying the physical event, the egg physically moves, or changing the density of the medium produced the egg moving, and knowing that an event or a gravitational force exists, that I can infer that that caused the movement. There is a big difference between the two.
Yes, there is a difference, Anthony, and it's called intellectual honesty. Let me give you a hypothesis. When I step on the gas pedal in my truck moves. I can cause my truck to move simply by stepping on the gas pedal. Now, I seem to have left out the engine, the transmission, the differential, the entire damn drivetrain. But I can show that simply by pressing on the gas pedal, the truck will move. And that's exactly what you're trying to do here. The force you're talking about is buoyancy. Back to your favorite reference library, Wikipedia. Let's just read what's in the yellow. For this reason, an object whose average density is greater than that of the fluid in which it is submerged tends to sink. If the object is less dense than the liquid, the force can keep the object afloat. This can occur only in a non-inertial reference frame. In other words, something's moving, which either has a gravitational field or is accelerating due to a force other than gravity, defining a downward direction. The center of buoyancy of an object is the centroid of the displaced volume of the fluid. You cannot simply leave out gravity. You cannot simply say it is only density that's causing this. Buoyancy is dependent on the force of gravity. It cannot be omitted, Anthony.
Surprisingly, perhaps one of the most common confusions in thinking about causation, or even among philosophers, in this case Rumpus, is to get mixed up with the inference. Do not make this mistake. Talking about you, Rumpus. One finds in this subject a kind of demonstration which does not carry with it such a high degree of certainty as that employed in geometry, and which differs distinctly from the method employed by geometers in that they prove their propositions by well-established and incontrovertible principles, whilst here principles are tested by the inference which are derivable from them. The nature of the subject, light, permits no other treatment. Well, thankfully in scientific method we do have other treatment. It's called scientific method. So it's only where you do not have any other treatment can you infer cause. But thankfully we do. We have scientific method.
And including gravity is not introducing or inferring another cause, Anthony. It is simply correctly stating the actual cause of the effect you're seeing. Here's the final 3 minutes and 30 seconds of Anthony's video.
If you assert that gravity in any way caused something in this experiment, that means you are adding a secondary cause. Adding by inference. If you add a secondary cause by inference, you fall outside of scientific method because you can't infer an extra cause when you've already got one that you've manipulated. You can't infer a secondary cause and remain within scientific method. If you wish to move outside of scientific method, sure, be my guest. Infer that gravity caused in any way whatsoever the effect that we just witnessed, which was the egg moving. But you do so outside of scientific method. And we know by definition, if you are not complying with scientific method, you are practicing pseudoscience. I am staying within scientific method, and I am using my cause and my effect relationship, and I am demonstrating it with using this. I've changed the density of the medium, and the egg has displaced. Within scientific method, the cause is that and only that. You cannot infer extra causes. That takes you outside of scientific method. So, in anticipation of any reaction to this experiment in the video underneath or the comments underneath, if you assert that there is gravity acting on this in any way whatsoever, you are outside of scientific method and engaged in practicing pseudoscience. Unless you can show me a citation within scientific method that allows you to disregard the cause, the salt, the medium change, and then substitute an alternative one instead, or including adding to, then you are outside of scientific method. You are practicing pseudoscience. Just by way of footnote, it's interesting to think that the mass of the Earth is below this table. The huge Earth ball that we're supposed to live on. And that is pulling that egg down, isn't it? Apparently. Yet when I added an extra bit of mass to this, the mass below the egg is increased. But for some reason the egg went up. If mass really attracts mass, why didn't the egg go down? It's a rhetorical question. I don't want any answer. Just merely an observation. But if you're going to infer that gravity in any way whatsoever did something in this test...
You mean like being responsible for buoyancy? You mean like being honest about what the actual cause is? Is that what you're talking about, Anthony?
Unfortunately, you are working outside of scientific method. You're practicing pseudoscience. And nobody on the ball side would want to engage in pseudoscience, would you? The cause of the movement of the egg was changing the medium's density. I caused it by doing that. The effect was it increased a little bit of pressure at the bottom, which displaced the egg. It moved. Newton said there was a force. So I've caused it. I did it with the salt. Gravity didn't do it. It wasn't the independent variable, was it? Can you science, bro?
Let's look at what pseudoscience is. Pseudoscience consists of statements, beliefs, or practices that are claimed to be both scientific and factual, but are incompatible with the scientific method. Pseudoscience is often characterized by contradictory, exaggerated, or unfalsifiable claims, reliance on confirmation bias rather than rigorous attempts at refutation, lack of openness to evaluation by other experts, and absence of systematic practices when developing theories, and continued adherence long after they have been experimentally discredited. The term pseudoscience is considered pejorative because it suggests something is being presented as science inaccurately or even deceptively. Those described as practicing or advocating pseudoscience often dispute the characterization. Anthony, the floating egg observation isn't an investigative experiment in the first place. It's an unfalsifiable demonstration that literally billions of school kids have already seen. The outcome is not in doubt. It simply shows buoyancy in the fact that two forces, one of which is gravity, are acting on the egg. Now, purporting to conduct an experiment around a well-known, well-understood phenomenon, and then declaring the outcome to be proof of something other than that phenomenon, while at the same time ignoring the actual cause of the effect, is the very definition of pseudoscience. And issuing admonitions to the rational world to ignore other potential explanations for the observed phenomenon simply flies in the face of actual science and the scientific method. Again, a near textbook definition of pseudoscience, but that seems to be what you're into. Anthony's outro follows if your monitor is still in one piece. Hope you liked the video. If you did, please don't forget to like and subscribe. Gladys, we're out of here.
Exactly, he's just gone off wildly into this quantum eraser dogma land where they prefer to live, about independent dependent variables, and so he's just trying to prove forces because there's an effect as a result of changing the independent variable, i.e. the thing that is the cause in his mind, although of course he doesn't like the idea of any cause has more than one factor, because of course you've got the density of the liquid, you've got the force of gravity. In other words, there are multiple factors and he can't cope with that. Like, Nathan doesn't understand that an effect is the result of more than one factor. And
yeah,
so
apparently he doesn't understand that an equation can contain more than two factors.
Yeah. Yes, more than one factor. No,
more than one factor actually.
Yeah, exactly right.
An independent variable is the presumed cause.
There can only be one independent variable and one dependent variable in an experiment.
The independent variable is systematically manipulated by the investigator. It is the presumed cause.
Think of the experiment as a cause and effect exercise. The independent variable is the cause factor.
Here's a fun question for Riley. What's denser, an egg or water? If all that matters is relative density, then the egg should sink.